My name is Pratik Patel, and I'm your host for today's Lunch and Learn. In this session, we'll explore, data center solutions that can really help you create value, achieve the best ROI, and really just, up your data center game. So if you think about it, we've actually had a lot of discussions over the past quarter. But what I wanted to do is I wanted to actually address one thing that kind of came to my attention today. I know there were some partners that actually didn't get the Grubhub credit that when they registered in that. So if you have, please, if you're attending right now and you haven't received it, reach out to me directly, and I'll make sure that we can kind of do something here for you. So reach out definitely if there's any kind of problem from that end. But let's kind of get started from from the overall session here. In January, we explored how sustainable data center practices really factored into business decisions, especially as they were related to new technologies like hybrid and multi-cloud. Sustainability practices were found to really have that positive impact on the company's bottom line and operational expenses, proving that sustainability is a concern for business as well as the environment. In February, we spoke with industry experts regarding how easy it is to build a hybrid environment. We learned that making an informed decision, having accurate and relevant information really determines what happens to your technical debt. And if you're not sure what technical debt means, definitely reach out to me, because I think that was a really good discussion we had in February. And due to the rapid advancement in cloud computing, business have numerous options in managing their applications, data, and workloads. Plus, with the rise of digital transformation, the demand for robust and flexible data centers has never been higher. So when it came to this final event of the quarter, several of my partners, channel partners, really requested that we kind of discuss, how they can address, some of these concerns that they've kind of mentioned over the past year. First is really, the rising data center cost. The second is really persistence of software-defined everything, the exponential growth of data volumes, and finally, the continually evolving security landscape. So basically lots of different threats that are out there. So, for that reason, I enlisted the assistance of AMD and Lenovo to help us understand the solutions and, really that can really help to really size an opportunity and really accelerate transformation. And joining me today, we have Michael Detweiler, a senior manager with a server business unit with AMD. Michael, thank you for making time for us. Could you tell us about your day and what your day is like as a senior manager and what initiatives you see that are really key for 2023?
Yeah, sure. So thanks for having me, everyone. I think like most people, looking at um, a server market in these trying economic times, questionable global economy, questions about what's going to happen. My day is consumed with how do we gain share facing these sort of challenges. So I spend a lot of my time within customers, as well as sellers at OEMs and partners, trying to help them understand the advantages that we can bring to businesses. And sometimes there is a cost of doing nothing instead of just kicking the can down the road.
Perfect. Yep. Thank you, Michael. Next, we have Jason Minchin, an AMD technical account manager with Ingram Micro. If you've been with the Lenovo team before or you've dealt with them, Jason's name is pretty familiar to you. Jason, thank you for joining us today. Please tell us about your role as a TAM and really discuss, maybe a unique use case, that kind of excited you.
Me too, ask.
Oh, sorry, I think you're muted. Oh, there you go.
Sure. Yep. Yeah. So my primary role as a technical account manager here at Ingram Micro is technical enablement, which is a fancy sounding word. Really, it just means that I'm a partner-facing technical resource. So I'm here to assist with whatever needs partners might have in terms of design and sizing. I'm free to do training, webinars, provide just general technical advice, situations where someone might need a technical resource that they don't have internally for a customer call. I'm always happy to join in those types of scenarios as well. So really just baseline technical stuff to help out with maybe some gaps that they might have in their own internal knowledge. Obviously focused primarily on AMD, but I also have a lot of knowledge around Lenovo and the other OEMs as well, and can help in most scenarios. Yeah, and then in terms of kind of a exciting use case that I saw recently, one that I kind of like or like to point at because it really kind of highlights the power of AMD EPYC processors, and also kind of tangentially is related to cloud computing as well, which I know is a major topic for you and Lenovo hybrid cloud. It's for a company that's they're a cloud vendor. Their name's Shadow. They do cloud gaming, which is kind of a really big booming industry at this point in time. You've got lots of huge companies that are trying to get on this boat. NVIDIA's doing it. Microsoft is doing it. Amazon tried to get in on it. Google tried to get in on it. Basically, the idea is to have a database a data center of servers that are able to emulate high-end gaming PCs so that customers can log in, play video games through the cloud using the data center hardware. And this company, Shadow, had originally built out their data center using competitors' CPUs, Intel CPUs, and 4 GPUs in each server. And they were finding that their CPUs were acting as a bottleneck. They weren't getting the full power. They weren't able to meet their original goal, which is to be able to have each server emulate 8 high-end gaming PCs. So when it came time to do a data center refresh, they decided to take a look at AMD growing in the server business. They went through and tested a bunch of different AMD EPYC CPUs, eventually ended up deciding on the 7543P from our previous Milan generation, and found that they got about a 65% performance boost over the previous systems out of that. So I just kind of find it to be an interesting story. Another thing I like about it, and the reason I chose to share it, is because it's a publicly available success story. So I'll share a link in the chat for anyone who's attending and wants to read a little bit further into Shadow and what they do and how that scenario played out.
Perfect. Yeah. Thank you, Jason. I know esports and gaming is booming right now. It's always that's always an awesome topic to talk about. Thank you. Yeah. Then we have Matt McQuarrie, a solution sales specialist for AMD with Ingram Micro. I'm so glad you could join us, Matt. Could you share some details about your role and what you see as some of the biggest challenges that your partners are facing today?
Thank you, Pratik. And yeah, absolutely, I can. So, I mean, essentially, the rewording of the term is what was formerly referred to as a market development specialist. So some of my day-to-days are pulling and reviewing pipeline and monitoring the sales cycle across all of the OEMs here at Ingram that sell EPYC-based data center solutions. POS reporting for internal purposes, for vendor purposes, and even for partner purposes. Managing and monitoring our vendor incentive program with AMD, and education training, mindshare on AMD products, and that's internal and external also. I would say the biggest challenge faced since I've been in role here at Ingram has been around supply chain and lead times. And trying to come up with solutions that are readily available when the turn time's important.
Perfect. I love that supply chain story there because Ingram Micro, Lenovo has an SMB Express program that could definitely work for that to help with the supply chain issues. So I love that part of it. And then finally we have Joe Murphy, a channel solutions architect with Lenovo and the co-host of Lenovo's partner technical webinar. I'm so happy to have you on my call, Joe. I know you don't really need an introduction, but I would love to hear about your background and also really about that weekly webinar that you have.
Sure. Hi, Pratik. Hi, everybody.
Okay.
I was at IBM for a lifetime, and then in 2014 I was part of the acquisition that Lenovo made, getting the x86 business, and so I've been working pre-sales technical with the channel pretty much since October 1, 2014 with various partners. And when the pandemic hit, we stood up a weekly call to start sharing content with our partners. So every Friday at 2 o'clock, it's open to partners. It's not open to customers. It's a pretty simplistic email distribution list. So if you're interested in joining, just drop me a line. Give you an example, some of the topics. This week, we're going to be talking about Weka. Next week, we're going to be doing kind of a comparison of the different SDI offerings, what we call Think Agile, HXMX, VX. And then after the Easter holidays, we're going to bring in our corporate security guys and have them come in and give us an update on the security story for Lenovo. So just always trying to bring good content to the folks. We try to have some fun every Friday afternoon.
Yep. I definitely love your dad joke. So I think it's a great event to join if you wanted to join. So definitely I recommend it. And then just to note everyone, Joe specifically is I actually asked him to come on for one reason, because he's going to be demoing a special tool that Lenovo uses to size opportunities. Once you see it, you'll be like, yeah, Ingram Micro, please get me in touch with Lenovo because we want to use this tool. So definitely, it'll be great. So we'll have that towards the end. And one thing I wanted to do is I wanted to acknowledge Sam Schmidt. I know she's on the call today. Sam, if you could get on and just introduce yourself, because I think you're key to the overall Lenovo, AMD relationship.
Thank you, Pratik, and thank you to everybody on this panel today. It was really fun, pulling this together. I am Samantha Schmidt. I am the account manager for Ingram Micro. So I've been with AMD a short or long 7 months, managing both the client and the server side of the business, working with all the OEMs inside this ecosystem. So I'm excited to learn from these guys every day, and I am also an added resource if anyone on the call needs anything for both sides of the business. So thank you.
Perfect. Yeah, thank you, Ms. Sam. So just a little bit of mechanics before we begin here. First, like Shelley mentioned, it's being recorded. So if you don't want to be on camera or don't want to be seen, please turn off your camera. And also, to minimize background noise, please ensure you mute your microphone. Next, we'll be sharing the recording once it's posted on YouTube, and we'll have some follow-up instructions towards the end. And finally, please put all your questions in the comment box, because I think that's really where we're going to be able to, get a better interaction. I believe that's it. So let's get the conversation started. Matt, let me begin with you. Recently we were discussing how the traditional data center has really changed due to the adoption of hybrid and multi-cloud environments. Can you kind of help us understand how AMD and specifically the AMD EPYC processors are really integral to the data center conversation?
Yeah, absolutely. So if you want to take a look at AMD's commitment to advancing technology in the data center, it's essentially something they were looking into and forecasting before the real hard push in that direction took place. So they were, looking at the focus on shorter SLAs, HPC and machine learning and AI, and increased virtualization. Basically understanding that footprint's expensive and that the compute needs are exceeding that footprint on many like on-prem locations. And understanding these changes, AMD's R&D was really around advancing the ability of data center processors, currently holding over 300 plus world records in performance and the densest core count solutions available in a single processor at 96 cores in their Genoa. So the core count provides a significant advantage over the current competition with nearly a 3-to-1 ratio right now. With the ability to either have more compute in a given footprint, or just being able to have headroom and add more capacity because of those advancements in their processors.
Okay, yeah, so I agree, because when we talk about hybrid or hybrid cloud, we forget that, hey, there is an on-prem component to it, and we just talk about the cloud part of it. So I definitely love that. So then, Matt, now that we understand the value of AMD, really, what are some of the benefits and challenges, that you've kind of observed for businesses that are looking to really identify, which processors to select?
So, I think one of the big benefits in choosing a processor from AMD is around the fact that that they're feature-rich processors. The features are available across the stack, so there's no tiering. Essentially, you're buying the core count and the frequency that you need. You don't need to worry about like a bunch of additional terminology or classification. You're really looking at what core count and what frequency of a processor do I need, and do I want like the latest and greatest if we're looking at going with a Genoa solution or a Milan solution for data center. As far as one of the biggest challenges, I think we're still struggling overcoming the legacy thinking that you have to populate 2 sockets inside a server. I still see comparable quotes come across as that, knowing 100% it's not necessary, and it actually slows down the final solution as well. Meaning the 1P solution will exceed the performance of the 2P at similar core count and frequency. So that's one of the struggles, is kind of the legacy thinking and still getting mind share and education out there.
Perfect. That sounds
And
like
just
exactly my
and just
viewpoint.
to be clear, populating a second socket does not give you redundancy. Some people think that that's not the case.
Nope.
So
Thank
no
you.
active or active passive, huh? Okay. So then, Jason, to piggyback on, what was just kind of mentioned here, could you kind of help us understand the different AMD, data center processors that are available, and really, how do you go about identifying which processor is right for, for the different workloads that your partners need?
Yeah, sure. So, yeah, like Matt mentioned, obviously the main focus of AMD's data center processors is on their core count, their energy efficiency, and then Matt didn't really go into it, but security is a big play in that area too that we might talk about a little bit later in this conversation. So those are kind of shared across the entire CPU stack. Any AMD processor you're going to get is going to have those, but then there are some specialty models within, which I think are worth spending a little bit of time on. Matt already mentioned the single socket versus dual socket discussion. So most of AMD's processors can be used in a dual socket configuration, but the P series is one that we kind of like to focus on a lot. Those are the ones that have a P somewhere in the name. Those are specifically designed for single socket solutions. And the nice thing with AMD and those P series CPUs is because of the core counts that you get on AMD, we're talking all the way up to 96 cores on a single CPU with the current processors. A lot of times, I would say most of the times that I run into, you can accomplish the necessary number of cores on a single CPU. So those P series CPUs allow you to kind of trim out some of the fat when you only need a single CPU. You're getting rid of things like Infinity Fabric and these kind of deep technical features that I won't get too deep into, but it saves a little bit on the cost, lets you optimize power usage and things like that. So that's one of them. Another one that comes into play every now and then is, I don't know that there's an official name. I always call it the F series. So these are the CPUs you see that'll have an F somewhere in the name from AMD. These are lower core counts, but they're much higher individual core frequency and clock rates. So ideal for workloads that either can't utilize multiple threads or ones that can utilize multiple threads but simply benefit more from having that high single core frequency. There's still a lot of them out there, especially in legacy applications. A lot of those aren't going to be able to take advantage of the fact that you have 96 threads in your system. They're more focused on that individual core. So in that type of scenario, look for those F series CPUs. And another really cool one that I think we're going to see starting to get more and more attention as time goes on are the X3D models. Those are the ones that have an X somewhere in the name. So they're really unique. They utilize AMD's 3D V-cache technology. Again, that's a really complex technology that we could get deep into the weeds, but that's not really the idea here. So just keep in mind, it means basically you're getting 3 times the L3 cache, which is the cache memory that's stored directly on the CPU. In the current models, it can go all the way up to 768 megabytes. It's going to go up over a gigabyte in the next series that comes out. So these are really good for any workload that can take advantage of that cache. Database servers are a huge one. You can see huge performance improvements on database servers using those X3D models. So those are kind of the different SKUs within the stack. And then in terms of deciding what is best for an individual user, every user is unique. Selecting the correct processor, in my opinion, is it's a matter of asking the right questions. So you want to make sure that you're going in and asking those questions, or getting someone who is able to go in and ask those questions of what's the customer's doing, what type of workloads are they running in their environment, what problems are they seeing in their current environment, which is one that I see a lot of people kind of skip past or not think of, and then taking the answers to those questions and applying it to what CPUs are available to find the one that best fits their needs.
Perfect.
I'm
So
also going to add in a link to we have tools, Epic Tools, and we have a processor selector tool, because that really a lot of times is the first question you get, which is, okay, I understand what you're saying. This makes a lot of sense. How do I know which one's right for me? You know, to Jason's point, it usually is a several question layer deep conversation. But for a lot of customers, they're less sophisticated than you think. And it's like, look, let's start with what you're buying today because we know Intel's the incumbent. Let's start with what you're buying today and try to give you a most apples to apples comparison, either at a price level or a performance level, to level set. But Jason's right. It always helps to ask those questions, which is, hey, what are you buying today, or what are you evaluating today, and why? Let's start there, because they might be savvy and know where they have bottlenecks, and which is why they want a high frequency processor, or because they can take advantage of the cache. Other times it's like, well, this fits my budget, and it's like it's as simple as that, and it's really not a long conversation. So there's a lot of there's a lot of ways to take that, but start with get familiar with the Epic tools. Not just a processor selector tool. We have some fairly sophisticated virtualization TCO tools that have a lot of knobs to turn, and also get into the sustainability aspect with greenhouse gas emissions.
So are these tools available to the channel partner community, or is this something that, they
They're
would need to
public
come to AMD?
online. I just put a link to it, amd.com. They're public and available.
Excellent, thank you. So, great. Michael, I had a,
And there is a cheat sheet. I don't know, Sam, if you want to find the data sheet. There's all online. We have data sheets available for this, but yeah.
Oh, excellent. I love cheat sheets. They always
Yep,
come in
lots
handy.
of collateral coming.
Perfect, thank you. So, Michael, this quarter's theme is really hybrid cloud. And I'm constantly reminded that, for a hybrid, we're talking about cloud computing, the processor type or even vendor, not really a big concern for a partner. What are your thoughts on this, and really why should processors play, a key role in a customer's decision-making process?
Well, so I agree and disagree with that. A lot of times they don't think that the processor really matters because they're not looking at that. They're looking at what problem am I trying to solve? How am I improving my status quo? But I can guarantee you, to a cloud provider, the CPU makes a huge difference, right? Because you're talking about, if we can deliver better performance or better core density or differentiated feature sets, that opens the door to them in terms of flexibility of the type of instances that they can offer, right? And it totally changes their TCO equation. And so those things filter down to a customer or partner level in terms of, for general compute, generally you're going to get better performance per dollar from an AMD instance, just because economy of scales come to play in terms of being able to offer more cores in a server, better core density at a rack level. That directly translates into performance per dollar improvements. When you're talking about having the highest performing processors, having compute optimized or HPC optimized instances lets customers get answers to questions faster time to results. That's a direct impact on your business. And then, we mentioned security. We have some pretty unique features that have been adopted by Azure, by GCP, that are available through and supported by OS and hypervisors like VMware, by your kind of your standard commercial Linux flavors like SUSE and Red Hat. Um, those get used, and yes, for if someone's looking at hybrid cloud and they're looking at what's available in the public cloud, hey, this offers me the best security. They might not be looking that, oh, it has AMD in it, but it has AMD in it, because the cloud providers saw that as a differentiator to offer confidential instances to their customers, and then to be able to take that same technology and deploy it on prem, so you have a seamless way to whether you're bursting to the cloud, or you just want to have common architecture between your cloud and your on-prem. That's huge. So we have a number of instances among the public cloud, lots of enterprise class platforms from our OEM partners, especially Lenovo. So you really have a kind of a seamless solution to deploy.
So along those lines, I understand that security is really a top concern for every business, because they're really worried about, the security implications of managing data across multiple environments. So then how does AMD ensure security for today's, workloads, applications, and environments?
So we've taken a hardware-based approach. So starting with even our first generation EPYC back that we launched in 2017, we have an AMD security processor. It's actually an ARM processor built into each one of our CPUs. And so that does a couple of things. One is it enables secure boot technology or like a trusted firmware, so that customers know, hey, when I boot, that my firmware hasn't been tampered with. I'm all good, and that's something that we work with our OEM partners. Lenovo has baked that into their BIOS and their firmware. So that it kind of starts with that, right? But that security processor also houses over 500 encryption keys, which is significant because that enables the ability to isolate VMs and containers in a same system. So you think about healthcare, you think about financial services, where protection of data is paramount. Public cloud, where they want to be able to offer security to where folks have a concern of using third-party infrastructure. It houses those keys that are used in that sort of technology that has been adopted and supported by VMware, Rails, SUSE, those types of folks. The important thing here is this is all hardware based, so you don't have to do any changes to applications. It is about getting the support from the OS and the hypervisor. There's a performance overhead of 1 to 3%, so it's almost like in the noise, application dependent, but it's not a significant performance hit when you talk about these security features. And then we have some other things too that protect against, if someone has direct access to a system, like physical access, you can flip a bit in the BIOS and it encrypts 100% of system memory. So think of edge deployments where you don't know what the physical security is like, or co-locations, or third world country deployments, things like that, right, in the military, where you want the most the most advanced security you can get. We've got a number of technologies there too, but it's all hardware based. It doesn't require a heavy lift or any lift from an application standpoint. It's invisible to the application, and it's really about getting the right support from the OS and hypervisors.
Perfect. Yeah, thank you. So Jason and Matt, to make this a little bit more interactive, I thought we could work on a sizing example. Let me share my screen because this was the example that we were kind of discussing previously. Sec here. Okay, so to the channel partners that are on the call today, if you see this particular example and recognize it, you should, because it's part of the Technical Solutions Cloud Certification exam. What is that, practice exam? So definitely, if you're not sure how it was solved, definitely reach out to us because we could definitely help with that. But a typical story, you have a regional reseller that that has a large data center, has some old outdated equipment in there, and they've just bought another retailer. Now they're trying to consolidate all that because they're experiencing access delays, lots of other issues, and then they have privacy and regulations that they need to worry about. So the overall gist here is that after you as the salesperson actually had several meetings with them, you actually get them to run an analysis on their existing infrastructure, something similar to what that Joe will be kind of showing. And they show a certain output of number of server cores, memory capacity, but you're trying to say, okay, I want to actually upgrade my systems, but also reduce my footprint, and also talk about really just having some overhead. So my two questions to Jason and Matt are really, if I take this particular example, what is my minimum number of cores that I would need for the solution, and then really how many servers will the customer need? And I know with your core count, that number will that will be much significantly less than the 34 that they currently have. So sorry, a little bit more than you wanted to hear, but go ahead if you want to kind of talk about how you go about actually figuring this out.
Yeah, sure. Well, I will say this is the ideal scenario when we have all of this information. We almost never do, because when you've got this information, it turns it really into a math problem. So you look at it. Well, what do we got? What do we got here? We've got their workloads. They're running on just over 1,000 server cores. Looks like we've also got a VDI environment that's kind of baked into that as well, though, where you've got about 6,600 workers that are using a core apiece and 4 gigs of RAM, and then you've got around 500 power workers who are also in that VDI environment, using a little bit more horsepower, obviously being power users or power workers. They've got 2 cores each and about 8 gigs of memory. So at that point, it just kind of becomes an addition problem. So you take that workload environment of the 1,000 server cores, you add in those office workers with the 6,600 cores, and then take 540 times 2, 1,080 additional vCPUs, and add that into the equation as well. You end up coming with 10,532 virtual cores, which is important to keep in mind here. So we're talking vCPUs, not actual physical CPUs. If we needed 10,000 physical CPUs, we're going to have a lot of servers there. So that gets us into subscription ratio, which is again a little deeper in the weeds than I want to go here. So I just kind of went with a conservative estimate here of around 3 to 1. That means you've got about 3 virtual cores to every 1 physical core on your CPU. So that condenses us down to needing around 3,500 physical cores. Oh, and sorry, one piece I skipped over is kind of adding the 20% in overhead in. So that 10,000 cores is already accounting for the 20% overhead that we want as well. So in terms of physical cores, we know we need 3,510 physical cores. Now we can play with that number a little bit. I mentioned 3 to 1 subscription ratio. You can push that all the way up to like 5 to 1, which would drastically reduce the number of servers we need. And given the environment and the fact that they're on 34 servers, I have a feeling they're already around that 5 to 1 ratio, but that's going to cause some degradation in the performance. We don't really want to do that if we can avoid it. And with the core counts we have available on AMD, we can easily avoid that without taxing the CPUs much. So again, we're just breaking it down to a math problem now. We need 3,500 cores. So we've got a bunch of different ways we can approach that on AMD. I kind of put together 2 options, which is a deeper discussion that we need to have around, do we want to have dual core systems, or do we want to have dual processor systems or single processor systems? And there's a whole conversation around that we don't have time for here. But really what it comes down to is we can either do 28 servers with a pair of 64 core CPUs each, or if we want to go with the single CPU options, we can do 36 servers with 96 cores each, and then kind of balance the RAM across those. We need around 31 terabytes total, but that's easy enough to get to with the server counts that we're talking about. So not a huge consideration there. And again, then it just becomes a conversation around the benefits of dual CPU, the benefits of single CPU, and which one works best based on the customer's use case, the performance they're looking for versus the cost and their budget.
Yeah.
There's other conversations that we can have as well. I mentioned X3D earlier. This is a retailer. They've got 250,000 items. I bet you they've got a beefy database that's somewhere in the back end for the servers that's hosting the database. Maybe we want to talk about those X3D model CPUs and bring that into the conversation. So there's a lot of additional discussions, but at this point, we've drilled it down to, okay, we need this many servers with this many CPUs each having this many cores, and we kind of build out from there and get into the weeds with the customer to decide exactly which CPU is going to be the best one for them.
Okay. So then I did have one question on here. Basically we're assuming everything is 2 gigahertz. Let's say the customer says, hey, 2.5, 3. I'm not trying to make you do more math here, but how would that factor into the overall, overall calculation for you?
Sure. So, I mean, really at that point, it's going back to the stack. It doesn't change the math that much. It becomes more a matter of where we're looking in the stack. If they're looking for 3 gigahertz, we can do that, and we can still keep the same math, not necessarily with the 96 core one. That may complicate the single CPU option a bit, not necessarily in terms of being unable to do it, but we may need to expand the footprint and add more servers in, because we're not going to be able to do a 96 core CPU in 36, or we're not going to be able to do a 96 core CPU with 3 gigahertz base frequency because the thing would literally burst into flames. The cooling is not there yet for that type of technology. We're getting there. We'll get there soon enough, but we're not there yet. So we may need to add more servers to the stack, maybe go with like a 64 core 3.0 gigahertz, one of those F series models that I was talking about. But yeah, when we're talking 3.0 gigahertz, really we're just kind of constricting the stack. We're going to kick everything out of there that doesn't have an F somewhere in the product number and just concentrate specifically on those F SKUs. We can still get up to 64 cores on a single CPU that way. So that would be where we'd want to hone in that scenario.
Perfect. Yeah. Thank you, Jason. I loved how you walked through that example, because I think, a lot of my partners, I've actually helped them with a lot of the certification trainings. This is where the, where they have a problem, where they just don't, they have a problem putting everything together. So I'm glad you were able to do that for us, So, yeah. So then, Michael, one of the things we keep talking about is AMD and Lenovo. So, the way I wanted to kind of ask this is really, AMD and Lenovo really, have had a long-standing partnership. But you got to provide insight into why, these types of partnerships are really important for AMD, and, how does it really benefit my channel partners?
Well, I mean, I think it starts with building trust. I mean, I think that's the importance of any partnership. Specifically on the server side, customers want they don't want headaches, right? They want to buy something they know is going to work because what they're using now works. And so it's about building that trust, and that's why we work closely with Lenovo on different solutions. Whether it be HCI solutions, different appliances, things like that. But I think there's actually a real uniqueness to the AMD Lenovo partnership, and that's because if you think about it, neither one of us are the 800-pound gorilla when it comes to market share in the U.S., right? We're both aggressively gaining share, and that's good. But there's a real opportunity if we kind of lock arms and say, look, we have a differentiator together because we think that there's a better solution here. We certainly, on the AMD side, we certainly think there's a better solution for the customer. And let's face it, people that are incumbents, OEMs that are incumbents, processor vendors that are incumbents, they don't want to initiate a change with the customer because that starts thinking, oh wow, there's another option here. That introduces risk into the equation, and they don't want to do that. And so AMD and Lenovo have a real opportunity to go in and say, hey, Mr. Customer, I'm looking out for your best interest, right? People you're dealing with now aren't going to tell you about this solution because you know what, they got your business, but I want to build your trust. Here's a different solution for you to look at. There's a real opportunity there to go do that. And I think it really, really works well, specifically with Lenovo, because of the portfolio and the partnership we've built on the client side. So if you think at commercial client from a laptop perspective, workstation perspective, Lenovo for a time had the only Threadripper based workstation on the market, and you guys and Lenovo completely flipped the market share on its head and from a workstation space. So we have a footprint in enterprises, and now it's time to really double down on that partnership and take advantage of that that footprint we have and go in with a solution that our other partners and your other partners on the CPU side aren't talking about.
Joe, what are your thoughts on that?
It's a really important partnership. Michael called out trust is really important. I also think there's some proof of the trust. Just look at the benchmarks that we've got running on the EPYC processor. I think we're up to 80 on the EPYC processor, and we're very aggressive with making sure that we're current. The new EPYC 4 out there, the Gen 4, we've now got 25-ish number of benchmarks. All this is public in Lenovo Press. So working very tightly. The other thing you guys talked a little bit earlier was about the security. And so all of those things that Michael talked about root of trust and platform firmware resiliency, we have embraced all of that so that we make sure that our firmware, Xclarity Controller, UEFI, are not corrupt. We know that they're solid. We know that there's no bad characters playing there.
Okay.
By the way, the other thing that's interesting, if you think about the commitment and the solutions that are out there and the traction, 2 years ago, I think there were 2 platforms in market, Epic-based platforms in market from Lenovo. Fast forward to today, I believe we're at 8 across enterprise, HPC, um, appliances, HCI appliances, things like that.
Right.
And there's more coming. So like there's a
There's
real
more coming.
commitment on both sides. And I think there's to my earlier point, I think there's a real recognition from both sides of the house here in terms of what is possible and the potential that we have of this partnership.
Michael called out, we're not the 800-pound gorillas, except in the HPC market, where we are the 800-pound gorilla, and we are teaming with AMD, because they're also, if they're not the 800-pound gorilla, they're like 750 and putting on some weight, because they are definitely the processor that the HPC crowds want to go for.
Perfect. Yeah. Thank you, gentlemen. Michael, since we're kind of talking about this partnership, can you kind of walk us through like an example or a use case so we can kind of understand really that the complete solution that kind of works together?
Yeah, I mean, I think it starts with, understanding the problem you're trying to solve, right? I mean, if it's an HCI, kind of opportunity, you start with the solutions that are available, right? If it's HPC, I mean, you start having those conversations around, what are your constraints around, power or space or budget, things like that. Cooling, can you water cool or air cool, things like that. So it really kind of starts with, hey, what problem are you trying to solve? And then it's about building that trust, right? Evaluation units or POCs are always great, but those could be expensive. They're not available all the time. I think that's why case studies are so dang important, because people want to understand, hey, this person's like me, right? They buy like me, they're just like me. If they can do it, I can do it. That helps. We've put someone earlier mentioned the world records that we have together. There's a lot of published, like performance briefs, application briefs, things like that show, hey, this has been tested, this is tried and true. So there's a lot of resources out there designed to build trust and show that, hey, this stuff's going to work. And not only is it going to work, it's going to really, really perform well. And so it kind of, you kind of got to just start at the beginning, and you got to sell them on the value prop, and then you just have to prove it and prove it and prove it. And a lot of times it's a turnkey solution, right? I mean, and it's an appliance. It's built specifically for this purpose, no problem, right? And other times it's, in an HPC environment, you might have selling to a university that has, 500 users that are running 300 different applications. They can't possibly test all 300 applications, but you go towards building that trust. What are your main ones you're running, and then being able to show, hey, by the way, it's been deployed at, these 30 other institutions that are kind of similar to you. HPC tends to be one where we have a lot of case studies, just because you have a lot of public institution. It's with public taxpayer money, so they're more than happy to speak about what they're spending their money on, because it's public knowledge. The enterprise space tends to be more difficult, just because you have folks that that's their secret sauce, and they're not, whether it's legal or PR, they're kind of, handcuffed in terms of what they can do. But there's a lot of good proof points out there that we can point to.
Yep. Thank you, Michael. So I'm putting a link in the chat. That talks about that proof and the use cases and those case studies, success stories that Joe kind of mentioned as well. So a lot of different collateral that you can use on there. So definitely look at that link. But I want to kind of turn the page a little bit and talk about something different. Jason, with Kubernetes and containerization really emerging as that key for achieving that portability and consistency across that multiple cloud environments that we talked about. How does an AMD really enable portability and consistency that's really needed for those modern applications?
Sure. Yeah, so containerization is obviously a huge buzzword in the industry at this point. It's kind of like the next logical evolution of virtualization. It's where everybody's kind of going at this point, and AMD has recognized that for a while, and definitely making sure that they have the tools available for people to be able to take full advantage. So, I mean, I guess to start off, the big thing, containerization, it's supported on all AMD CPUs. You don't need to buy into a certain tier. You don't need any kind of special features or anything like that. If you've got an AMD EPYC CPU, it supports containerization. AMD does also work hard to make sure that there's a lot of documentation available publicly to both partners and end users. So they've got tuning guides that are out there and readily available on the AMD website for Kubernetes or Hadoop or Docker or whatever platform you may be using. And then in terms of what kind of makes AMD stand out here, it's coming back to security again. We keep coming back to that word with AMD. It's a big deal. So security is a major focal point in the containerization space for AMD. They've got EPYC SEV, which stands for Secure Encrypted Virtualization, is fully enabled on Kata containers. So that's really something that's unique to AMD and something that AMD offers that the competition doesn't have available right now. And then going further than that, where AMD really is starting to focus in is in the GPU space in the data center, at least when it comes to containerization. So AMD has a lot of pre-built containers using ROCm, which some of our partners on the call may not be familiar with because it's kind of new and emerging. The word they may be more familiar with is CUDA, which is the other GPU guys. That's what they use. AMD has ROCm. So there's a lot of pre-built containers that use ROCm. You basically plug and play based on the workload and what it is that you're trying to accomplish out of those GPUs. You can download that container right off of AMD's website, plug it into your environment, spin it up, and it's ready to go right out of the box.
Perfect. Thanks, Joe. I know I didn't really give you as much time as I promised, but could you kind of first talk about what this tool OneIQ is, and then show us a demo? I appreciate that.
Yeah, absolutely. So you guys saw a problem that Jason worked on about, this is the scenario and this is how many cores, and Jason called out that a lot of time you don't get that information. So how can you size based on that? And Lenovo has teamed with a company called OneIQ to be able to gather statistics from the install base and then be able to pull it into a tool that you can have access to, your customers can have access to, and then we can do a sizing based on that. So do a pretty brief demo here. This is the tool. It's called OneIQ. Lenovo has access to this. So to start this, you would need to reach out to Pratik and team. He'd reach out to Lenovo. We would get a workspace set up. We'd add you as a collaborator. We need to know the name of the customer of who's going to install it, because they're going to install a data collector that's going to sit on a desktop, a laptop, a small VM. It's just going to connect to all of the vCenters and servers to be able to start collecting data. And then the data is going to start getting collected, and we bring it together, and we see that this is all sample data. So in this case, there's 5 machines out there, and it gives us an idea of how much compute and how much memory is out there. Now, what's kind of interesting is at this point, I've got a decision. I can either download this into a spreadsheet, lots of great details here, or I've got kind of a nice report format that comes out that I can then share with a customer. This gives a sample of what it looks like. But kind of more interesting is, now what do I do? And now I can go into a design and I can call out my great AMD processors. I can call out that I've got 20% growth like Jason talked about in his use case. And I can include or exclude VMs or vCenters. You can get very discrete with this. In this case, I just took all 5 servers that we're replacing. And then we get some examples of replacements. In this case, they gave us a 3U, 3 U's of 3 servers, each one 1U, using the 7542, a 32 core processor. And then this example, we've got 2 servers, 2 larger servers, using the 64 processor, the 7702P. And the costs that you see there are list prices. Your prices will vary, of course, but this gives you a really good place to start from. And it has a lot of validity backed into it because it's based on the customer's data. Again, we call this OneIQ. It's pretty straightforward to set up. It does require some commitment from the customer that they're willing to install the collector. And then it takes about, oops, wrong page, It takes about 7 days. And the reason it takes 7 days is we want to make sure we get all the peaks. If the customer says they only want to run it for 2 days, that's fine. They want to run it for 30 days, that's fine too. It will elongate the sales cycle. My rule of thumb is 7 days. So I get all the peaks during the week and I get all the weekend. And then it takes us, 1 or 2 days to kind of crank through the numbers and come up with some of the possible solutions. So that was a very quick demo of OneIQ.
Perfect. Thank you, Joe. I knew I could count on you to make it quick, so definitely I love that. So, I think we're coming to an end here. So, a question for all four of you. Really, as technology leaders, how do you envision the future of the data center, and how do you really see it evolving in the next 5 to 10 years? Joe, what are your thoughts on this?
So I think that this is kind of a back to the future kind of question, because you've heard some conversation about the processors and heat, and they are generating more heat. The high-end processors that have all the sex appeal here are over 300 watts. And so we're having to cool these differently than we did 5 years ago. And so the reintroduction of some kind of liquid cooling is happening. Lenovo has already got it in place on some of the AMD servers, where we've either got kind of a radiator system, a closed loop system, or we're actually connecting into customer supplied water. So this takes me back to the beginning of my career, when I was working on IBM mainframes and had to bring the water in to fill them up. So the processors, the compute is requiring more and more cooling. And so to me, it's back to the future with some kind of liquid or water cooling.
Perfect. Jason, what does your experience say here?
Yeah, well, I think we're kind of already seeing, and we're going to continue to see, this idea of getting more for less becoming the data center mantra. So energy costs are increasing, budgets are tightening, everyone's thinking about the big R word, and is it going to happen? And at the same time, we've got this conflict going on, because we've got the budgets decreasing, but commute demands are growing, because now the big topic, especially right now, is artificial intelligence and machine learning, and what can it do for us? How can we bring this into our data center? And so these have got all these really high compute needs. You need a lot of compute to be able to do machine learning. While at the same time, budgets are tightening. So it's going to become a real challenge for IT professionals working within the data center, as well as partners and those of us in distribution, to try to squeeze more and more and more compute into a smaller and smaller and smaller budget. So, it's really going to become a matter of finesse and trying to figure out a way to do what the customer wants in the smallest machine possible.
Perfect. Yeah. What is Matt? So what about you? What are your thoughts on this?
Oop, you're on mute,
Sorry,
Matt.
I think you're on mute.
If I was looking at a crystal ball, I would say the continued or increased focus on sustainability. So a couple of people now have kind of touched on the impacts of our IT and our compute needs. As the needs ultimately increase, all energy is waste dumped as heat, right? So a more efficient processor is less heat dumped into the environment, so less cooling for the actual server needed, less cooling for the physical structure that it's in. So you combine all of that and that focus on reducing carbon footprint. The engineering, it's going to continue to be a focus. How can we make more sustainable IT or compute products?
Perfect. Michael, I'd love to hear your thoughts on this topic.
Well, I was going to give a view, but all those were really good answers, and they actually align to AMD's kind of long-term strategy. So let me kind of touch on kind of how that aligns, I think, to what AMD's doing. So sorry, I was jotting down notes. So let's start with the liquid cooling one. That's a really interesting one. That certainly we see more liquid cooling. We have certainly, from an engineering standpoint, been working with a number of, I'll call it alternative cooling, whether it's water cooling, immersive cooling, things like that, sort of customers, because for folks that have the power, can deliver the power, think really large, 30, 40, 50 kilowatts per rack sort of thing, they're looking for density. Yeah, certainly we see a lot of liquid cooling already deployed, and that probably is going to go up as well. But what's interesting there is not everyone has that much power available to them, right? And so not everyone's looking for that amount of density. I think you're going to see where AMD's single socket strategy is, and just the proliferation of more single socket servers really start to take off, because not everyone's just going to blindly move to liquid cooling because a processor's hot. We certainly on our roadmap are looking at kind of TDPs and where they need to plateau in order to stay within air cooled environments. If you can move that to single socket, now you're talking about eliminating half of the processors. That becomes simpler to cool a 1U, a 2U kind of standard form factor server. And think about where we are today, right? We introduced a product with 96 cores. It's public that our next one is going to have 128 cores coming out fairly soon, first half of the year. We're not letting off the gas. So like compute capabilities and feature sets are continuing to move up and to the right. I think there's going to be lots of people that are like, you know what, that's a single one of those processors is enough compute for me, because it is a whole lot of compute. Now, HPC, public cloud, they'll continue to push the boundaries in terms of density and compute and things like that. But I think in the mainstream enterprise, you're going to see a lot of move to single socket. Then there's that kind of also looks at them doing more with for less, right? Because there are absolute advantages from an efficiency standpoint going to a single socket. It's not just buying and powering one CPU over two. It's the entire platform that goes into it in terms of size of the boards, the electricals that go into the board, the size of the power supply, the cooling solution, the entire cost and power profile of the platform itself, before you even talk about CPUs, goes down when you're talking single socket platform. So, I think that goes to Jason's point of, people are really going to be looking at how they do more for less. The single socket is a way to do that. AI, yeah, I mean, I think that's not a 5 to 10 year thing. That's a more like a 1 to 2 year thing. AMD's been very vocal about, our commitment to AI. I mean, we acquired Xilinx last year. Among lots of different IP, they do have some really interesting AI IP. We actually introduced it or announced a product called Ryzen AI at CES earlier this year that's going to be going into notebooks. So there's a lot of interesting sort of melding of IP within AMD that you're going to see coming out in the future years. Not just on the EPYC side, CPU side. Someone mentions Instinct from an acceleration standpoint, our accelerator cards, and you've got the Xilinx technology as well. So certainly we're well aligned, I think, from an AI perspective. And then sustainability, this has been a really big thing. We've been hearing about it from customers for a number of years now. There's a reason why if you click on that tools link that I sent, that we have a greenhouse gas emissions as part of those tools, so people can see what sort of impact on the environment their buying decisions are having. We actually have some aggressive targets. It's called the 30 by 25 initiative, which is to increase the energy efficiency 30x from 2020 to 2025 in HPC and AI workloads. And so this is absolutely kind of a forefront to our long-term strategy in terms of kind of where we're focused. And by the way, we do that in a number of ways, not just our own technology and architecture, but using the best process technology from a fab standpoint, different packaging techniques to increase performance as well. So we're well aligned with everything that they said, and I completely agree with them.
Thank you all for that, for those great insights. As we're kind of winding down here, I really wanted to state that, what I'm seeing is that based on today's discussion, it's really evident that the combination of AMD and Lenovo is really an excellent choice for organizations, that are really interested in deploying hybrid infrastructure. The joint experience of both companies in hardware and software really allows for that seamless, secure, and reliable experience. Additionally, AMD's EPYC processors really offer that industry-leading performance and efficiency that we mentioned earlier here, and then then we have Lenovo's Think System and Think Agile technologies, which really provide that unparalleled scalability, manageability, reliability, all the abilities that you could kind of think of there, which really make these solutions perfectly optimized for that hybrid data center. So really, as such, the way I see it is, whether customers are really, their aim is to modernize their data centers or optimize their workloads or even enhance their, business agility, AMD and Lenovo can really provide that power, performance, and flexibility that they need to succeed. And, what I wanted to kind of say here is really, I hope today's session really provided, valuable insights, one thing that we've done is, we you can reach out to Ingram Micro if you want to really learn more and really continue this conversation. And one of the things that we're going to be doing is, I know we're almost out of time here, but really we wanted to kind of have some follow-up activities. So you should look out for things coming from our side. And on a final note, I really wanted to thank my panelists, Jason Minchin, Matt McCreary, Michael Detweiler, and Joseph Murphy. Sorry, Joe Murphy. I know.
So formal. You're so formal.
I know. And and sharing their their valuable time, insights, and expertise. So I know last few seconds here, but really see you in April. Really have a great day. Bye for now. Thank you very much.
Bye bye. Thank you.
Thank
Thanks,
you.
Pratik. Thanks, everybody.
Thank you.